Welcome to GE142, Curves and Earthworks. We are now on our second module entitled Horizontal Curves, Simple Curve. So for this lesson, we will be determining what are the types of horizontal curves, and also we will be describing what are the elements of a simple curve and how it is being solved. So by the end of this module, you should be able to determine the types of horizontal curves, describe the elements of a simple curve, and solve problems involving simple curves. Now, there are four types of horizontal curve. So there is simple, compound, reverse, and spiral. So each curve is unique depending on the use and application. So starting with the simple curve. So simple curve is an arc of a circle. So meaning it is a part of a circle with radius r. So it is the most commonly used. So the radius of the circle determines the sharpness or flatness of the curve. So this means that the larger the radius, the flatter the curve. So yan yung simple curve. So ito yung figure niya. So that is simply the simple curve. Compound curve. So compound curve normally consists of two simple curves. So there is radius 1 and radius 2. So this is radius 1 and radius 2. So surveyors often have to use a compound curve because of the terrain. Say, so yung curve, this is a center line. So ito yung center line ng isang, say maglalagay ng daan. So say galing dito, so this is the starting of the curve, then first curve is nandito. Dito siya. So for example, merong obstacle dito. So mahirap patanggalin. So hindi mo pwedeng continue yung curve mismo, yung curve. So you'll have to make a larger curve para maiwasan yung obstacle na to. So that's why you'll have to use another radius for a simple curve. So yan yung compound curve. So they're curving and joined in the same direction. So now reverse curve. So what is reverse curve? So reverse curve consists of two simple curves joined together but in opposite direction. So opposite siya sa compound curve. So they're in opposite direction. So for the first one, the first radius is curving to the right, and now yung next na curve naman is curving to the left. But for safety reasons, the surveyor should not use this curve unless absolutely necessary. So for example, kung talagang short na yung terrain nyo or yung location, short na siya sa hindi mo pwedeng i-extend muna, kasi usually hindi pwedeng ganito na diretso na siya i-curve mo. So but mag-extend ka pa ng isang horizontal na road bago mo idagdagan yung curve mo para yung transition ng sasakyan, if ever na may dadaan, is smooth yung transition niya. So hindi yung biglang mag-iiba yung curve ng daan. So yan yung reverse curve. So now the fourth type of curve is spiral curve. So it is a curve with varying radius. So which is used on railroads or some modern highways. So it provides transition from the tangent to a simple curve or between simple curve in a compound curve. So sa next module, mga darating na module, i-explain na rin kung ano yung spiral curve. So ito yung pinaka-complicated na curve. Okay? Now, starting with the simple curve. So for the next figure, we will show the elements of simple curve and describe kung ano yung mga elements na bumubuo sa isang simple curve and yung mga abbreviations na ginagamit. Now, so ito yung example ng isang simple curve. So mayroong radius, mayroong length of arc. So we will discuss yung mga variables na nandyan. So starting with is point of intersection. So the point of intersection marks the point where the back and forward tangents intersect. So the surveyor indicates it one of the stations in the preliminary traverse. So this is the point of intersection. Itong PI. So if this is the center line, so diba sa previous discussion natin, in locating a final location of a road, ini-describe yung center line. So if this is center line coming from here, this is called the back tangent. And ito na yung center line or the forward tangent. So ito yung intersection ng dalawang center line. That is point of intersection. Next is the radius, of course. So your radius, yung radius ng curve na i-outlay. The next is point of curvature. So the point of curvature is the point where the circular curve begins. So ito yung start ng, so dito na nag-start yung curve natin. So beyond PC is a horizontal line na siya. But before PC is horizontal line. But beyond PC is doon na mag-start yung curve natin. Then point of tangency is where the end of the curve. So dito. So beyond PT na ulit is straight line na siya agad. So yan yung bale start and end of a simple curve yung PC and PT. Okay, so next is length of the curve. So simply kung ano yung length ng curve na to dito. Ito kung ano yung length na. Yan yung length of curve. So that is measured from PC to PT, of course. Then tangent distance. So tangent distance is the distance along the tangents from the PI to the PC or PT. So ito yung mga tangent distance natin. So from here, from PC to PI or PI to PT. So yan yung tangent. So tangent to geometry is a line intersecting a circle at one point. So that is at point PC or at point PT. So yan yung tangent distance. Intersecting angle. So intersecting angle is the deflection angle at the PI. So itong angle na to. Yan yung intersecting angle. So the surveyor either computes its value from the preliminary traverse station angles or measure it in the field. So also sa geometry, if this is I, this is also I. Okay, so equal yung central angle at O and the intersecting angle at PI. So equal sila. Same angle. So next is the long chord. So long chord is the line from PC to PT. So sa geometry, long chord is a line passing through a circle at 2 points. So ito yung long chord ng simple curve natin. Next is the external distance. So external distance is the distance from PI to the center of the curve. The middle ordinate is the distance from the center of the curve to the midpoint of the chord. So that is the external and middle ordinate. Next is the degree of curve. So it determines the flatness and sharpness of the curve. So there are two definitions commonly used for degree of curve, the arc definition and the chord definition. So i-discuss natin mamaya. So this is so if there is a point X sa curve natin, the corresponding interior angle is the theta, the degree of curve. So the center angle I could be the degree of curve for the entire curve natin. And then next is the deflection angle. So the deflection angle at any given point X along the curve. So if you have point X sa curve natin, so the corresponding angle derived from PC is what you call the deflection angle. So sa buong curve natin, ang deflection angle natin is I over 2. Yan yung deflection angle. So offset distance is the distance from point X perpendicular to the tangent. So from point X perpendicular to tangent, yan yung offset distance natin. Then central angle. So the central angle between PC and point X. So ito yung angle na yan. So now for the derivation of the formulas ng mga variables. So we will start with the tangent distance. So this variable. So by considering triangle PI, PT, and O, so this triangle, so considering triangle na to, so we have 90 degrees here and angle I/2 dito. So using yung sa trigonometry natin, yung SO, ka, TOA, kukunin natin yung value ng T. So, meron tayong T and yung radius yung gagamitin natin kasi maraming variable dito sa hypotenuse niya. So, meaning, we'll use tangent formula. So, tangent I/2 is equal to the opposite over hypotenuse. So, T over R. So, simplify that in equation, taking taking the tangent. So, tangent is equals to tangent I/2. So, yan yung formula for the tangent distance. So, ngayon naman, the middle ordinate. So, itong variable na yan. So, considering triangle Q, PT, and O. So, so dito, Q, PT, and O. So, originally, this distance is R. So, para ko yung distance na to, so this is R minus M. Now, given R and yung I/2, yung central angle natin, we will just use cosine. So, cosine I/2 is equals to R minus M over R. So, we simplify the equation. Middle ordinate M is equals to R times 1 minus cosine I/2. So, that is for the middle ordinate. So, next naman is yung long chord natin. So, considering triangle Q, PT, and O, Q, so same triangle, but yung gagamit natin is sine na formula. So, sine I/2 is equals to the opposite over hypotenuse. So, opposite is C/2 over the radius. So, long chord is equals to 2R sine I/2. So, yan yung formula ng tangent, distance, middle ordinate, and the long chord. Next naman is the external distance. Itong distance na to. Ito. So, considering triangle PI, PT, and O. So, yung unang formula natin, PI, PT, and O. This triangle. So, that is, this distance is R plus E. So, radius hanggang dito, then plus E. So, cosine I/2 is equal to R over R plus E. Now, so, simplify natin yung equation. So, transfer yung R plus E dito sa kabila. So, R plus E multiplied by cosine I/2 is equals to the R. So, i-distribute natin E cosine I/2, then R minus, so yung R natin i-multiply dito, then i-transpose sa kabila, magiging negative R cosine I/2. So, leaving only E sa kabila is equals to R over cosine I over 2 minus, so minus r na lang. So matitira, magka-cancel out yung cosine I over 2 dito. So, inverse of cosine is secant. So magiging r secant I over 2 minus r. So factoring out yung r, E is r times secant I over 2 minus 1. So yan yung formula ng external distance. Now next is yung length of curve. So formula of a curve is S is equals to the radius times the central angle. So that means that LC or yung length of curve natin, ito, is simply the product of R times the interior central angle I. So para i-convert natin into radians, we multiply pi over 180 degrees. So yun yung formula ng length of curve natin. So to summarize, tangent distance is r tangent I over 2. External distance is r secant I over 2. Middle ordinate is r times 1 minus cosine over 2. Long chord is 2r sine I over 2, and length of arc is 2 pi r I over 360 or ri times pi over 180. That's the length of curve. So yung involved lang na variables is the radius and the interior angle. So yan yung, as long as meron radius and interior angle, pwede makuha lahat ng mga variables natin. Okay, so the degree of curve, so as mentioned kanina, is based on two bases. That is the arc basis, where 20 meter is the length of arc for a 1 degree curve. So that means degree of curve 20 over 20 is the interior angle over the length of curve. Say if that is our simple curve. So where length of curve is equals to Ri times 180 pi over 180, so yung kanina. So magka-cancel out yung I. So ang matitirang na variable is d and yung radius. So solving radius in terms of d, that is 1145.916 over d. So yan yung degree of curve using arc basis. So the second definition is the chord basis, where assumes that each degree subtends a chord of, so dito naman yung 20 meter dito is yung chord. So yung kanina yung arc mismo yung 20 meter, but this time yung chord yung 20 meter at 1 degree na central angle. So considering the right triangle form, so itong triangle na to, considering this triangle, so that gives us sine d over 2 is equals to 20 over 2, so half, kalahati, this is 20 over 2, this is d over 2 dito, and yung radius natin. So r is equals to 10 over sine d over 2. So that is the chord basis. Okay, so we'll be solving some examples para mas maintindihan natin yung discussion natin. Okay, so problem number 1. So a simple curve has a central angle of 36 degrees and degree of curve of 6 degrees. So A, find the nearest distance from the midpoint of the curve to the point of intersection. Next is, so this is, nahanap dito is yung nearest distance from the midpoint of the curve to the point of intersection. This is the external distance. Then compute the distance from the midpoint of the curve to the midpoint of the long chord, joining the point of the curvature and the point of tangency. So this is the middle ordinate. So given. So meron tayong given na central angle of 36 degrees and degree of curve na 6 degrees. So using the formula degree of curve, we can find for the R. So degree of curve 1145.916 over D 1145.916 over, which is 6 degrees. So yung radius natin is simply 190.986 meters. So yan yung radius natin. Okay. So, diba yung sabi ko kanina, pag merong interior angle and radius, masasolve natin yung lahat ng mga variables. So, A is the external distance. So, formula external distance is radius times secant of I over 2 minus 1. So, radius is 190.986 times secant of I is 36 over 2 minus 1. So, E is simply equal to 9.829 meters. So, yan yung E natin. So, sa B, so that is the middle ordinate yung hinahanap. So, middle ordinate is R times 1 minus cosine I over 2. R is 190.986 times 1 minus cosine 36 over 2. So, middle ordinate is 9.348 meters. That is the middle ordinate and the external distance. Now, for the second problem, a simple curve has an angle of intersection I equals to 45 degrees and radius 200 meters. So, the point of intersection, yung PI natin, is at station 2 plus 982.84. So, first is compute the stationing of PT, the deflection angle at station 2 plus 937.7 from PC, the right angle offset from station 2 plus 937.7 on the curve to the tangent PC, and the compute the degree of curve using chord basis. So bago mag-start yung mga problem, you'll have to draw muna say kung example, yung ENS 161, mag-draw ka muna ng free body diagram to guide you sa magiging computation mo. So, dito, i-draw natin yung figure ng curve natin. So, say, meron tayong curve with radius 200. So, R, central angle I, which is 45 degrees. So, say, ito yung curve natin. Ayan. So, yung intersection angle natin, or yung stationing ng PI. So, this is PI at station 2 plus 982.84. So, this is the tangent distance. This is I. So, this is PC and PT. So, to get the stationing of PT, so from PI, meron tayong station. So, isosolve natin yung tangent distance. Makuha natin then yung length of arc. So, stationing of PT is equals to PI, stationing ng PI, minus, i-minus natin yung tangent kasi backward tangent siya. So, parang babalik ka sa pinanggalingan ng reference. So, to minus PI, PI minus T is stationing ng PC. Then, plus length of curve That is the stationing ng PT. So, hindi siya pwede na PI, pwede naman na PI plus tangent, yun na yung station ng PT. But here, it's different. So, since yung curve natin yung magiging center line ng highway na i-construct, so dito tayo mag-refer. So, babalik from PI to PC, babalik tayo, then, tsaka tayo pupunta sa PT. Okay, so first we solve the tangent. So, tangent is equals to R tangent I over 2. So, radius is 200. Tangent 45 degrees over 2. So, this will give us 82.84 meters. So, that is the tangent. So, first determine the stationing of PC. So, stationing of PC is PI minus T. So, itong formula to. So, this is equal to 2 plus 982.84 minus 0 plus, so since 82.84 lang siya, so 82.84 so stationing ng PC is equals to 2 plus 900. Okay, so finally, stationing ng PT is equals to stationing ng PC, which is 2 plus 900 plus the length of curve. So length of curve is the radius times the central angle times pi over 180. So stationing ng PT is equal to 3 plus 057.08. So that is the stationing ng PT natin. So, this point, this is 3 plus 057.08. Okay, so reminder, so if hinahanap yung PT, hindi pwede na i-add mo yung tangent na to. So, mali yun. Kasi ito na yung center line natin. So, if given the station of PI, so subtract mo yung backward tangent, makuha mo yung station ng PC, and then i-add mo yung length of curve, yun yung station ng PT. So, yan yung tamang way ng mag-solve. Okay? So, next is, okay, so erase natin. Next is to determine the deflection angle at station 2937.7 from PC. So, meaning, my point along the curve at station so say somewhere, so 2, this is 2 plus 900, so siguro somewhere dito, so that is say point X. Ayan. So if this is point X, this is the offset distance X, and the deflection angle. So okay, so para malaman natin yung length ng curve na ito, solve natin siya. So Lx is equals to 2 plus 937.7 minus yung stationing ng PC natin. So, length of curve from PC to point X is 37.7 meters. Okay, so yung formula kanina, length of curve is r times the central angle. So meaning 37.7 is equals to the radius times theta is pi over 180. So the central angle from, central angle from PC to X is equal to 10.8 degrees. So ngayon naman, the deflection angle is simply half nung central angle natin. So this is 10.8 over 2. So this is equals to 5.4 degrees. So yan yung dito, yung deflection angle dito. This is I. So yung kanina sa figure natin. So ngayon naman, the offset distance, right angle offset distance from station 937 from the point through PC. So if i-isolate natin yung triangle na yan, ito. So this is the X. This is the PC. This is the I natin. Okay? So, first is, solve natin yung chord. So, kuha natin yung chord muna. So, this is the C. So, to get the C, yung formula ng chord natin. Yung formula ng chord, C is 2R sine I over 2. So, C is equals to 2 times the radius, 200, times sine. This time, yung central angle natin is 5.4 and 10.8 over 2. So, this will give us the chord from PC to X, point X is 37.643. Okay, so masasolve na natin yung external distance. So external distance is C sine in the deflection angle. So 37.643 times sine of 5.4 degrees. So X is equals to 3.543 meters. So that is the external distance. So now sa D, so solving for D, D is compute the degree of curve using chord basis. Yung formula for chord basis natin is R equals to 10 sine D over 2. So meron tayong radius na 200, 10 over sine D over 2. So D is equals to 5.732 degrees. So yan yung degree of curve natin. Okay, so that's it for the simple curve. So we have an assessment question. A curved diversion road has a tangent AB with direction due north and tangent BC bearing north 70 degrees east. Point A is at the PC whose stationing is 12 plus 600. The degree of curve is 5 degrees. So compute the long chord of the curve. Compute the stationing of point D on the curve along the line joining the center of the curve, which makes an angle 40 degrees at E with the tangent line passing through PC. And what is the length of the line from D to E? So I want you to answer this as an assessment question.